Look, sa bawat frontline operation sa loob ng isang BPO o shared services hub, alam naman nating lahat na sobrang obsessed natin sa performance metrics, right? Bawat shift, may team huddles tayo just to talk about average call durations, QA scores, or SLA response markers. Pero bilang isang Lean Six Sigma Master Black Belt, ang pinakaunang concept na kailangan kong i-establish sa explainer na ito ay ito. Process improvement is absolutely not just about making changes. It's really about measuring your core operations scientifically and establishing stable control bago ka pa mag-attempt na baguhin ang kahit ano.
Para sa session natin, ito yung logic flow natin. We'll start with the metric trap, tapos move on to raw numbers to ratios, statistical process control, the rule of 8, median moving range, and we'll wrap up with targets versus control limits. The goal here is simple. Ilipat natin ang mga teams from pure emotional guesswork papunta sa stable, scientific control.
So let's kick things off with Section 1, the metric trap, o kung paano tayo makakatakas sa mga arbitrary targets.
This is honestly a universal headache sa BPO industry. Yung obsession natin sa raw SLA numbers nang hindi naman talaga natin naintindihan ang underlying system capabilities ng operasyon natin. Dito pumapasok yung fundamental Lean Six Sigma rationale from W. Edwards Deming. If you can't measure it, you can't manage it. Sa madaling salita, kapag wala tayong objective data, napipilitan tayong manghula or mag-rely sa emosyon. And what does that lead to? Magulo at sobrang magastos na localized reorganizations. Pero take note, ang pag-measure sa lahat ng bagay without any context is also a trap. It just leads straight to data paralysis.
Think about it. We are basically looking at dalawang magkaibang mundo dito. Sa isang banda, you have arbitrary targets. Ito yung pure chaos kapag minamanage natin ang operations based entirely sa superficial client desires or emotional guesswork. Tapos, sa kabila, you have statistical limits, which is all about objective data reflecting your true process behavior. Para makapag-build tayo ng institutional grade na operasyon, we absolutely must learn how to separate superficial goals from true data-driven statistical limits. Let's see how we actually do that mathematically.
Moving right along to Section 2, raw numbers to ratios, finding the true baseline.
Dito na papasok yung first real mathematical solution natin para ma-evaluate ng tama yung process behavior natin. Kasi let's face it, relying on raw, isolated figures, it's completely meaningless. Kung sasabihin mo sa akin na may 20 quality infractions yung isang queue, that literally tells me nothing without an operational baseline. Para magka-sense ang data mo, you have to transform it into ratios. Ang operational ratio is simply the total defect or metric occurrences divided by the total process volume completed. By getting this ratio and comparing it across consistent time periods, nakakabuo na tayo ng isang solid baseline.
So paano ba natin ito ina-apply sa totoong buhay sa production floor? Imbes na magbilang ka lang ng mali, you have your green belts or yellow belts monitor specific performance ratios. For instance, sa isang BPO setting, that looks like errors per log ticket, fatal drops per audited call, or rework cycles per client report. By switching to these ratios, binibigyan natin ang teams natin ng actual standard para masimulan nilang itanong yung most important structured question. Bakit nangyayari ang variation na ito?
Alright, Section 3, Statistical Process Control, which is all about proactive monitoring.
Let's be real here. Kung nag-audit ka lang ng ticket pagkatapos ma-finalize yung transaction, you are reacting way too late. Tapos na eh. The damage to the client relationship is already done. Kailangan nating i-shift yung mindset mula sa reactive na pass-fail auditing papunta sa real-time proactive tracking. By pulling small, randomized data samples over structured intervals, nakakabuo tayo ng isang control chart na may upper control limit, isang historical mean, and a lower control limit. Guys, this is your visual early warning system. Bago pa man bumagsak ang SLA nyo at makatanggap kayo ng penalty notice mula sa kliyente, you will actually see the degradation of the process.
Now, gamit yung control chart na yon, we can clearly identify two primary root structural causes of process failure. First is the drifting of the average. Ito yung unti-unting pagbabagal o pagdegrade ng baseline performance natin over time. Think of it like yung creeping latency na minsan nararanasan mo sa GCash or similar apps. And second, too much variation. Ito naman yung kapag nagiging sobrang erratic at unstable na ang galaw ng proseso mo from hour to hour.
Next up is Section 4, the Rule of 8, detecting shift and drift.
You know how it is, as humans, ang bilis nating mag-overreact sa mga short-term data blips. Makita lang tayo ng biglang spike sa AHT ngayon, panic mode na agad. Pero paano mo malalaman kung permanent system failure na ba to o sadyang outlier shifts lang? Dito papasok yung statistical trigger natin. Kung stable ang isang proseso, ang daily metric points niya normal lang na nagbabounce above and below the historical mean. Pero kapag nagtala ka ng 8 consecutive intervals, 8 sunod-sunod na data points na puro nasa itaas o puro nasa ibaba ng average natin, it is mathematically less than 1% likely na nangyari ito by chance. Meaning, may structural alteration na sa underlying system nyo. You need to investigate immediately.
At bilang mga modern process engineers, we definitely don't sit around waiting for a monthly retrospective review para makita yan. We can modernize this. Pwede nating i-set up ang Microsoft Power Automate, i-link natin yan directly sa live Excel datasets natin. The moment na mangyari itong 8-point statistical shift na to, Power Automate can instantly flag a supervisor para makapag-execute agad ng live floor interventions. Now that is real-time operational control.
This brings us to Section 5, Median Moving Range, and setting our action limit boundaries.
Okay, so yung rule of 8 is perfect for catching shift and drift over time. Pero paano naman yung bigla ang spike? Paano natin i-compute yung boundary para makatch agad yung mga extreme outliers at single-point special cause failures? We use this mathematical formula para makapag-establish ng definitive scientific alarm para sa sudden Q volatility. Action limit boundary equals mean plus or minus 3.14 times MMR. Ito yung exact boundary point na kapag may anomaly na lumagpas dito, you need immediate live floor intervention.
Let's break those components down real quick. Ang mean ay yung mathematical average ng historical data mo. Yung MMR, or median moving range, yan yung exact center value ng lahat ng sequential absolute changes mula sa magkakasunod na data points. Sa madaling salita, ang MMR is basically the mathematical representation kung gaano ka-volatile o inherently spiky mag-operate yung Q mo. Tapos yung 3.14, that's simply your statistical constant multiplier. Kapag pumalo yung metrika mo lagpas sa computed threshold na to, that is your definitive statistical alarm na may special cause failure na nangyayari.
And finally, our climax, Section 6, Targets versus Control Limits, the ultimate reality check.
Dito natin haharapin yung matinding friction sa pagitan ng kung ano yung gusto ng client at kung ano yung tunay na structural reality ng operations ninyo. Look at this hierarchy. Sa pinakataas is the client target, yung arbitrary SLA goal nila. Pero directly underneath that is your upper control limit or UCL. Guys, kailangan nating tanggapin ito. Ang SLA ay isang external desire lang. Ang control limits mo, that is the unfiltered mathematical reality ng kung ano lang talaga ang kayang i-deliver ng current system mo. Kung ang UCL ninyo is mathematically sitting above or below what the client wants, then the process is structurally incapable, plain and simple. Kahit gaano pa karaming pizza parties, agent coaching, or micromanagement ang i-apply ninyo, hindi niyan mafi-fix ang performance gap because the system itself is the problem.
So what's the actual solution? You have to physically redesign the workflow. Gamitin ninyo ang mga automated control charts ninyo, whether built in Excel or dynamically visualized sa Power BI to isolate these systemic process boundaries. Tapos, magpartner kayo sa mga green belts ninyo. You need to identify and locate those root vectors of variation. Mula sa input, i-trace nyo yung problema, tapos literal na i-redesign ninyo ang proseso para maprotektahan yung bottom line margins ng account ninyo.
So I'll leave you frontline leaders with this final provocative question. Paano ninyo i-redesign ang workflow ninyo para maprotektahan ang profit margins ng kumpanya ngayong alam na ninyo kung ano ang inyong tunay na structural baseline? It is time to stop micromanaging based on emotions and raw numbers and start engineering our processes purely based on scientific data and control limits. That wraps up our explainer on the blueprint of metrics. Ngayon, simulan na nating i-apply ang LSS logic na ito sa operations ninyo.